Alright, so let's take a look at these problems on these polynomial functions. Here they're wanting me to find the intercepts, wanting us to find the intercepts. To find the x-intercepts, you let y equal 0, so that y is the output of this function. So if we just take the left-hand side and let it equal 0, and then on the right-hand side, we want to factor this completely. They've given us the first part here factored, but this trinomial here we need to factor. So either by factoring or the quadratic formula, let's see, two things that multiply to give me 3, 1 and 3, but add up to give me 8. 5x plus 3x is 8. And then over here we have 2 minus 3x. So we have this zero product theorem that says if you have a list of numbers, and if you multiply this list together and you get 0, then at least one of the numbers in the list must be 0, maybe more. So either 3x plus 1 is representing 0, or 5x plus 3 is representing 0, or x plus 1 is representing 0, or 2 minus 3x is representing 0. So this gives us negative 1/3. This gives us negative 3/5, negative 1, and 2/3. So those are my x-intercepts for this polynomial function. So let's make that clear. These x-intercepts right here, these are my 4 x-intercepts. What about the y-intercept? Well, for the y-intercept, you let x equal 0. Using this function notation, we plug in 0 into the function. So this first term, or excuse me, this first factor, 3 times 0 plus 1. This middle factor, 5 times 0 squared plus 8 times 0 plus 3. And this last factor, 2 minus 3 times 0. So this first factor is just 1. This next factor is just 3. And this last factor here is 2. And I'll use y rather than function notation. And 1 times 3 times 2 is 6. So hey, my y-intercept is 6. Same directions. They want me to find the intercepts. So this time they don't factor it for me, but it is quadratic in form. So I can factor this. X squared times x squared gives me x to the 4th. And two numbers that multiply together to give me positive 36, but add together to give me a negative 13 or negative 9 and negative 4. This is a difference of perfect squares, so this factors to x plus 3 times x minus 3. And the same idea here, this is a difference of perfect squares, x plus 2 times x minus 2. This gives me x is negative 3, positive 3, negative 2, and positive 2 as x-intercepts. So these 4 are my 4 x-intercepts, and with the degree of 4, I know there can be at most 4, so we found all of them. In standard form, the y-intercept is always this constant term. If you plug 0 into this function, these first two terms are 0, 0 to the 4th, and 13 times 0 squared, plus 36. So if I use y, I could use the function notation if you'd like, f at 0, but I usually use y. And the y-intercept is 36. So here they want me to write a polynomial function. And it doesn't say it has to be in standard form, so I'm just going to write it in factored form and leave it in factored form. It's kind of nice that this polynomial function is going through the origin, because that allows me to pick any leading coefficient that I want. It doesn't say anything about the end behavior. It doesn't say anything about the multiplicity at each of these zeros. So there's a lot, infinitely many correct answers And this is how I would do it. I would just have exponents of 1 here. In factored form, if x equals negative 5, in factored form it's x plus 5. And here for 3/4, why you want 4x minus 3. Because if you set that equal to 0 and solved, you get 3/4. And here, 3x plus 1. So here's a polynomial function that has these zeros of x equals 0, x equals negative 5. If you set this equal to 0 and solve for x, 3/4. If you set this equal to 0 and solve for x, you've got negative 1/3, which is what they wanted. They said as zeros, which is just another word for x-intercepts, at 0, negative 5, 3/4, and negative 1/3. So, hey, here's the polynomial function that has those zeros. That's my answer. Now, this one's going to be a little bit more difficult because there's more information here contained in this graph than there was in the information that was just given. So let's take a look. From this graph, I can read the coordinates of the x-intercepts, but I can also read the coordinates of the y-intercept. I'm just going to call this function p for polynomial. It appears like it would be a polynomial because it's smooth and continuous. There's no sharp corners. I can draw the whole thing without ever lifting my pencil off the paper. And it does have one of our 4 end behaviors with down and up. Remember, it's either up and up, down and down up, or up and down. Now, I'm going to have to come in and use this y-intercept a little bit later to determine what my leading coefficient is. But as far as these x-intercepts, I can immediately jump in factored form, this negative 5, we write it as x plus 5. And the exponent that I'll pick there for its multiplicity is 1. I'm picking an odd number because at negative 5, this graph is crossing the x-axis, as opposed here at negative 2, where it's coming down and touching it and then turning and going back up. So I refer to that not just as a touch, but a touch and turn. But I think most textbooks just say touch. Negative 2 in factored form is x plus 2. Since it's doing a touch and turn, the multiplicity has to be an even number, so I'm just going to pick 2. I'm just going to say that that's squared. I could put it to the 4th power, to the 6th power, but 2 is going to be fine. Here it's doing a touch and turn at x equals 3. In factored form, we write that as x minus 3. And again, I need an even number, so I'm going to pick 2. In general, if it was a bigger even number like 4 or 6 or 8, you would still see it do a touch and turn, but it would be a little bit flatter. It would come in and be a little bit flatter down here when it does its touch and turn. Alright, so here's part of my answer. It's not my final answer yet because I had to figure out what this a is. Well, I haven't yet used the information of this y-intercept, 0, 5. When x is 0, the output of the function, which is the y-coordinate, is 5. So if I plug in 0 into this function for x, what do I have? Alright. The output we should get, it should be 5. So we need to make this a the correct value so that this product is 5. Alright, so let's solve this for a. 0 plus 5 is 5. 2 squared is 4. Negative 3 squared is 9. And 5 times 4 times 9 is 180. To get the a by itself, let's divide by 180. And we can reduce this fraction. And this reduces to 36, 1 over 36. So my final answer is that this polynomial function, it didn't say it had to be in standard form, so I don't have to multiply all this together, is 1 over 36, which is positive, and it's going up to the right, so it's good that that's not a contradiction. X plus 5, x plus 2 squared, x minus 3 squared. So there's my answer for number 4. What about for number 5? Well, here we want to do synthetic division. You could plug in -9 and do all of this arithmetic, but let's plug it in. Since the input into the function is -9, we'll do synthetic division with -9. I've given this to you already in standard form with no missing powers. So we just have to do the synthetic division, which the number is actually a pretty big number. Alright. So it always starts out, you just bring the first number down, you get multiplied by the number in the box, and I did this previously so that I wouldn't take a lot of time. You know, -9 times -19, 171. Add these together, 178. Multiply, and I get -1602. Add these together, and I get -1618. Multiply, and I get 14,562. Add 14,579. Multiply, and I get -131,211. Subtract 12 from that. Multiply by a -9, so it'll be positive. So I need to kind of scoot this over a little bit and give me some room. So -9 times this number, I got now I did this all with a calculator, and I wrote it down on a piece of paper, and that's where I'm writing, just copying this off of here. If I would key this in a number and multiply it by -9 to get this next number, and I get -106 to 3 digits of 8, and then a 3. So if you add this last column together, 106 to 8852. So f evaluated at -9 for this function that they gave us, I claim will equal this -106 28852. Alright. Now here it's wanting the list. It's not saying to actually solve it. So read the directions carefully, and you could save some time, because if you spend time trying to solve this and finding these zeros or the x-intercepts, that's wasted time. Well, the things that you want to check are, is this in standard form? Are the exponents in descending order, 4, 3, 2, 1, constant? Is there any greatest common factor? Well, 5 and 11 are both prime numbers, so there's nothing that's common to all of these. So I'm going to start with the factors of my constant term. And in this case, the constant term is this last term 4. So I'm interested in the factors of 4. And we have plus or minus. These are the integers that divide 4. And so it's positive or negative. So there's 6 numbers written there. We just use shorthand notation, plus or minus, to indicate positive numbers, and then the same set of negative numbers. All right, so now the leading coefficient is 5. So I have, boy, this is lagging. I hope this doesn't freeze up. Factors of 5. So the numbers that divide 5, since 5 is prime, is just 1 and 5. The list of numbers that they want, remember to put your plus or minus. This is the possible numerators. This is your possible denominators. So we've got 1 divided by 1. We've got 2 divided by 1. And 4 divided by 1. Now we move on to the next denominator, 5. We've got 1 divided by 5. 2 divided by 5. and 4 divided by 5. So there's our answer. We've got plus or minus. So there's 12 answers there. All of these positive values, then all the negative values as well. All right, so here they've given us a polynomial function, but they factored it almost all the way for us. They factored it part of the way. To find the zeros of this polynomial function, we set the left-hand side equal to 0 and factor the right-hand side completely. So we've got x plus 2. And then they expect us to factor this 4x squared minus 9. Well, 4x squared is a perfect square because 2x times 2x is 4x squared. And 3 times 3 is 9. So we can factor this 4x squared minus 9 as 2x plus 3 times 2x minus 3. Now this trinomial over here, we can factor it as well. We've got 2x times x. We want two numbers that multiply together to give me 6, or excuse me, negative 6, and the add together to get the 1x. So I've got 4x minus 3x, which is 1x. So hey, we've factored that completely. Let's look now and see if we can simplify this before we try to solve the x plus 2 and another x plus 2. The in factored form, we generally write that as x plus 2 quantity squared. And the 2x plus 3, excuse me, the 2x minus 3 and the other 2x minus 3, there's two of those factors. And then we can write down x plus 3. So we've got a 0 at negative 2. We have, well, let's put it in the table down here. If x plus 2 is 0, then x is negative 2. If 2x minus 3 is 0, then x is positive 3 halves. And here, if 2x plus 3 is equal to 0, x is equal to negative 3 halves. So the multiplicity for this first factor is 2, that exponent 2. Since that's an even number, we describe that it intersects the x-axis by doing a touch and turn. Here with the 3 halves, again, the multiplicity is 2. That's an even number, so it's a touch and turn. And negative 3 halves, that's to the first power, that's a multiplicity of 1. And that's just simply a cross. Alright, let's move on to this next one. Is it the last one or next to last? It's next to last one. Alright, so let's take a look at it. Now, I don't have any tricks or anything to factor this, so I'm going to have to use my rational zero theorem. I need to look at the factors of 35. The factors of 35 1, 5, 7, and 35, and of course plus or minus in front of each one of those numbers. Now the leading coefficient is 2, so we have factors of 2, and kind of starting to almost fall asleep here, so hopefully I don't do that on the video. If you hear me snoring and fast forward to the end, 1 and 2. Alright, so my list of zeros to check then, these are my possible numerators, the factors of the constant term, and my denominators, the factors of the leading coefficient. So the list, this is regenerated when you divide everything by 1. When I divide it by 2, 1 half, 5 halves, 7 halves, 35 halves. Alright, so We need to check these numbers in this list to see if any of those give us a zero remainder. So we'll use synthetic division. I've done a few ahead of time because what I'm afraid of, if I just sit here and go through this list, there might be a lot of them that aren't zero. So if we come up to 7, if we get to this positive 7, I know from in class that somebody told me that was a 0 and it worked out to be 1. So let's see, this is in standard form with no missing powers of x. So I've got 2, negative 5, negative 68, 35. The 2 comes straight down. Oops, almost 14 minus 5, 9. Negative. Oh, why did I put negative? Because I'm getting tired. When I get tired, I have a tendency to make some silly mistakes. Hey, we get 0. Alright. So that means that I can factor this original polynomial. So this g of x that they gave me, I took 7 from my list and said that, hey, I believe that x minus 7 is a factor of this. And when you divide this original polynomial by x minus 7, you get 2x squared plus 9x minus 5. So let's set this equal to 0 and solve this equation. X minus 7 and 2x squared plus 9x minus 5. I believe that factors to 2x times x, and this is 5, so this is minus 1 plus 5, because that's 10 minus 1, which is 9, yeah. Alright, so let's see what we would have here in our table. The zeros of this function are 7, x equals 1/2, and negative 5. So all of these have a multiplicity of 1 because the exponent here is 1. So all of these, because this is an odd multiplicity, is a cross. Alright. Hey, the last one. Alright. Actually, I'm going to pause this and get a drink real quick, and I'll be right back. Alright, so I'm back. Alright, so let's take a look at this guy. It's the same directions as the previous two. My polynomial's in standard form. There's no greatest common factor. I'm going to look at the factors of the constant term being a prime number. That's kind of nice because my list will be short. And the factors of 7 are just 1 and 7, plus or minus 1, and plus or minus 7. Leading coefficients also prime, 2. So that's plus or minus 1 and plus or minus 2. So the list of, if this graph intersects the x-axis, and if it intersects at a rational number, then it will be in this list of numbers that we're going to generate here. It doesn't say anything about irrational numbers, and it's no guarantee that any of these numbers in the list are an x-intercept at all. Remember, x-intercepts are also called zeros of the function. So if we have 1 divided by 1 and 7 divided by 1, we just get 1 and 7. But here, when we change the denominator to 2, we've got 1 and 2 and 7 and 2. Okay, so that's our list. So we need to do synthetic division with the numbers from this list. And let's just peel off our coefficients of 2, negative 15, negative 8, 14, and 7. We're hoping that we get a 0 down here. That's what we're looking for. So let's try 1. The 2 comes down, we multiply, we add, we multiply, and we add again, and we multiply. And hey, we have a 0. So that's kind of nice. Sometimes you'll go through that whole list and you won't find one, or maybe it's the last number that you check, unfortunately. So this g of x has a factor of x minus 1 because in factored form we change the sign. So since it started out x to the 4th, this is x to the 3rd now. So we've got 2x to the 3rd minus 13x squared minus 21x minus 7. Well, I don't have any x methods or anything for this 3rd degree. I can't factor it by grouping or anything like that. So the only thing I can do is notice that I have the same list of possible x-intercepts for this, that the factors of negative 7 are the same as the factors of positive 7, and the leading coefficient is 2. So I look at the numbers in this list. Alright, so could be that one has one could be a 0 with a multiplicity greater than 1, but I don't think so. I think here I made it, oh, excuse me, I made it so that we would have to do it with a fraction. I need to pause this and get another drink. I'm sorry, I'm going to cough into it. Well, I'm back again, so hopefully I'm recording. Let's peel off these coefficients of 2, negative 13, negative 21, and negative 7. Let's see what we have. The 2 comes down. Negative times the positive is going to be negative, and half of 2 is 1. Add these together. Negative times the negative is positive, and half of 14 is 7. Add these together. Get a negative 14, so negative times negative is positive, and half of 14 is 7. And I get this equal to 0. So hey, I'm able to factor what I've highlighted there, which is kind of nice. So we have this g of x is equal to x minus 1. And in factored form, this negative 1/2 is actually 2x plus 1. Because if you solve this, you'll subtract 1 and divide by 2. Now these guys are going to be x, since this was x to the 3rd, this starts out x squared. And these are all even numbers. So I'm going to factor a 2 out from there. I'm going to move my table up here. And we're getting close to the finish line. With all these being even numbers, I'll just factor out a 2 and get x squared minus 7x minus 7. Now, see, this guy gives me a 0 of 1. This guy gives me a 0 of negative 1/2. I knew that by looking up at the synthetic division. The 2 doesn't give me a 0, but this quadratic, I can't factor that. So I'm going to have to use the quadratic formula. So I take the opposite of b, the opposite of negative 7 is positive 7. I square b, so if I take negative 7 times itself, I'll get 49. Minus 4 times a times c, well, c is negative 7. All divided by 2 times a, which a is 1. Alright, so what I have here is 7 plus or minus 49 plus 28, and that's 77. So I can't simplify that radical. So let's shrink this up, and we're ready to give our answers. Let's do it in the form of a table, because remember the directions. It wanted not only the zeros, but the multiplicity and how it intersects the x-axis. So we had x-intercept is 0 of 1. We had 1 of negative 1/2. And we had this irrational number from the quadratic formula, 7 minus radical 77 over 2. And we have this 7 plus radical 77 over 2. So all of these multiplicities are just 1, which means we don't have any touch and turns, that these are all crossing as they intersect the x-axis. Alright, so hey, that's our answers, and I will talk to you later. Bye.